This conference will now be recorded.
Hello, hello,
Hello, good morning.
morning. How are you, Deepika?
I'm good, thank you. How are you all doing?
Guys, can you hear me my voice, right? Hello?
Yes, we can hear you.
Oh, that's good. So, what's our last class? I think we just seen a one sample jet test with one tail, right? Tell me, is it correct or not?
I think we did hypothesis testing.
This
Yeah,
testing
hypothesis testing, z-test, z-test hypothesis testing.
we are accepting the null hypo or alternate hypo based on the jet test, right? Okay.
Z-test.
So based upon the problem statement, we are considering the which test we are using. Now, I just want to give you another question. Okay, so you just read that particular question and try to understand and what could be the problem, which kind of test we should go for apply it. Okay, so for example, so there is a blood glucose level for absence patients have a mean of 100. Okay, so which means that the mean value of the glucose level of population is, it's 100 with the standard deviation. So what is the standard deviation here? It's a 15. So I can read it, you just listen it. Okay, so a glucose level for absence of patient have a mean of 100 with the standard deviation is 15. Then after, a researchers think that diet high in raw construct will have a positive or negative. So here the word is, so the researcher is trying to researching on one particular diet. If the people are doing that particular diet, whether the glucose levels are positive or negative. So that means let me consider this is my normal distribution. Okay, so this is the 95% of the data. Okay, and negative or positive, right? Let me consider this is the negative, let me consider this is positive. You don't know what level it is, right? So here it can increase or decrease. You have to go for find out whether the glucose level can increase or decrease. If it is increase means it's a positive, decrease means it's a negative, right? That's the reason here if I'm considering the alpha is my significant value, then alpha by 2, so this is the level region is alpha by 2, and this one is it's a alpha by 2, right? So this is the 95 percentage. So positive or negative effect on the blood glucose level, a sample of 100, sorry, a sample of n, that means my n value is it's a 30, sample size is 30, patient who have tried, so that kind of diet 30 people they tried actually. So by the time the glucose level for the 30 people mean is, the glucose level of the 30 people mean is it's a 140. Okay, and this hypothesis raw effect, what could be the effect, what could be effect? So whether your glucose level can increase or decrease, that is your question. Okay, so here my first step is we have to be fix what is null hypo. My null hypo is my sample, sorry, my population mean is 100. Okay, so what could be my null hypo? My null hypo is positive or negative, right? So positive or negative in the sense, so whether my glucose level can affect or not, in the sense not 100, not 100. So here my question is, when the patients are doing that particular diet, the glucose level can affect or not. That means previously the reality is the mean is 100. Okay, so if I do that particular diet, my mean can affect or not, affect in the sense not equal to 100. And with which kind of test I should go for apply? It's say there is positive level or negative level, then increase or decrease that I want to find out, it's right. So that is the reason I have to go with two-tailed test, two-tailed jet test. Why jet test? Because of I know the population information. Okay, see, my significant value is, let me consider my alpha is 0.05. By the time, what is my alpha by 2? It's a 0.25, right? So 0.25 in the sense, this is the 95 percentage is 47.5 percentage here and 47 percentage of here, right? Okay, so now I just go and check the t table. I just go and check my t table. So if my alpha value, one two tail test, right? If it is a two tail test, the alpha value, the significant value, the jet table chart. So if I go with any one of it, see, Where is jet table? Jet table two tile test.
You can use the Excel formula. In Excel, you can use the norm dot inverse formula to get the Z score.
You can use it. The question is, so usually simple thing we want to go ahead actually. So no, every time remembering is tough, right? So we have to use standard. So 1.96. Usually that value is 1.96. So see, you can see. Okay. See. Hmm. See, in this particular situation, this is what it's a minus 1.96. Okay, this range is plus 1.96. So here, this range. Okay, so the reason is it's a 95 percentage, right? Here it is a 95 percentage. Here is the 2.5 percentage. Here is the 2.5 percentage. So 1 minus alpha by 2. So one value, alpha value is 0.05 by 2. So 1 minus 0.025. So which means 0.975, right? So 0.975 means on which range we have it? Tell me. 0.975, right? This is 0.975. So it's a 0.06 plus this value is 1.9. So 1.9 plus 0.96. So 1.96. How you are calculating from this jet table? Are you getting my point? So here it is very simple thing. Alpha value is 0.05 I consider, but when it is the two-tailed test, then my levels, it could be 1 minus alpha by 2. This is the value you have to be consider. You have to be considered to find out the left tail and right tail values. So 1 minus 0.05 by 2, which means 1 minus 0.025, so which means 0.975. Okay, so this is the value where we can find in this particular table. So this is the 0.975. So exactly at top and left. So 1.9 plus here it is the 0.06. So total it is 1.96. So this is the value. If it is the left side, then it could be the minus. If it is the positive side, then it could be the plus 1.96. Okay. Same thing. If it is the one tail test, then it will be very simple thing. And for one tail test, if in case if it is a one tail test, alpha value you're not at all modifying. 1 minus alpha in the sense 95, right? 0.95 in the sense on which range we have it? 0.95, 0.95. Yes, this range. So it's exactly the middle of this one. That means 0.045, and it's quite exactly left side is 1 minus 6. Sorry, 1.6. So 1.645. If it is the one tail test, then you're not changing the this significant value. Okay. So alpha value you're not dividing if it is a one tail test. If it is a two tail test, then what you should do, alpha by 2 you have to apply, and that value you have to check in this particular table. Clear? Is it clear my point? So from the jet table, my critical values are, what is my critical values? Tell me. What are my critical values? What are my critical values? Anyone? It's a minus 1.9.
1.96.
It's a plus 1.96.
96.
Plus 1.96. Okay. Okay. So just remember those particular values. Once if you know these particular values, then which formula we have to use it to find the jet score? Why sometimes it is not dropping? My jet score formula is sample mean minus population mean by standard deviation of the population by square root of n. Tell me guys, mean is 140, right? 140, and population mean is 100 by, and standard deviation is 15 by square root of n. What could be the value? So 40 by, your n value is 30. What is the value? Can anyone tell me? 15 by 40 by 15 by square root of 30.
14.60.
14.60. So here the 14.60, it is in this range, right? It's more than 1.96. It's not in between. It is not in between 1.96. If the value is in between minus 1.962 plus 1.6, then you have to be considered accepting the null hypothesis. But my value of this 14 is, it is not in this particular range. It was more than this value. Maybe it can be less than this value. If it is the less than this value also, it could be affected. If it is the more than 1.96 also, it could be affected, right? So my 14.6, it could be more than the 1.96, which means that rejecting the null hypo. So what is mean that rejecting the null hypo? So rejecting the null hypo, what it is stating? So the state is if patients are doing that particular diet, okay, they affect the glucose level. It can affect the glucose level in a positive, in a more state is in a positive way. So their glucose levels can increase. Patients are doing that particular diet. What diet it is? Corn starch diet. Okay. If the patients are doing corn scratch diet, and that time the glucose levels are increases. It's in a positive way. Okay. If you're getting the negative value here, then that particular situation, that negative value, it could be the less than this value, which means you're rejecting the null hypo and you're stating that the alternate hypo is not equal to 100 in the sense, which means the glucose levels are decreases. Okay, so the glucose levels are increase or decrease also you can find out, and the meanwhile the glucose is effect or not also we can figure out with the help of this particular test. Did you got my point? Can you please solve this particular question? I can just give you 5 minutes of time. Yes, is this done? If you're done, then please let me know.
It's done.
Okay. So we'll do the one
Hi,
more. Yeah, tell me.
I have one small thing. How long does the class take? I just have an appointment at 9:15. I need to go. So
What is the time now?
it's for us, it's almost 9.
In a 15 minutes, I can wrap it up. Okay.
Okay, thank you.
Yeah. So we have one more problem actually. That problem which is stating that jet test of two proportions. For example, when we have the two groups, I want to compare these two groups actually. Okay. So that particular situation, we can go with jet test of two proportions. Just side heading jet test of two groups or two proportions, whatever it is. See this situation, you have the two groups. This is group A, and it could also, it's a population only, and this is another group. This is also some group of data. So I just want to compare these two groups. Previously, you have the same group. From that one, we are taking some sample data and you're comparing and you're checking that particular data is valid or not. But this situation, these two groups are different. I want to compare it actually. That situation, the jet test of two proportions formula or the test, it can doing a wonderful job. See, for that one, I just want to give a small question for you for understanding. You're testing the two flu drugs. Okay, let me consider the drug A. This is the drug A, and this could be the drug B. So the drug A works on 41 people out of the 195 sample data. So this is the drug A which is working properly on the 41 people out of 195 people. Okay. In the same way, the drug 2 which is we are doing, which is working on the people is 351 out of the 605 people. So here we are taking the 605 is the sample data and you are applying the drug on the 605 people and we are getting the best result out of that one 351. In the same way, the drug A, you are taking the 195 people and it is working on only on 41 people. Now, I want to compare these two drugs. Okay, which one is the best for it? This particular situation, I can take my alpha value is, it's a 0.5 percentage. That means 0.05. Okay, so what is null hypo which is stating, my null hypo is stating drug A and drug B performance is same. That means both drug A and the drug B both are performing the same. So I want to prove it. I want to give the evidence for that one. Both are different, which is not same, which is not equally performing. So I want to prove it. Both are different. That is, alternate hypothesis testing is proving that. This particular situation. So from the jet table, alpha value is 0.05, right? So when alpha value is a 0.05, what could be the my levels here? It's a minus 1.96, and here it is the plus 1.96, right? And here I want to calculate the Z. So here the Z is formula is different. It's not previous formula. Proportion 1 minus proportion 2 by square root of overall proportion minus overall proportion into 1 by number of samples or number of samples of two groups. So this is the formula we need to remember. So this is the from this particular formula here, n1 is sample of data of drug 1. It's a 195. Is it 195 or not? From the problem statement, yes, here it is a 195. And sample of drug 2 is, it's a 605. Now proportion 1 in the sense drug A proportion. The drug A proportion is, it's a 41 people, right? It is working on the 41 people, right, out of the 195. So what is the value here? It's a 0.21. In the meanwhile, the drug 2 proportion I want to find out. So which is working best, which is working fine with 351 people out of 605. What is the proportion of drug 2? 0.58. Yes. Now the overall proportion formula is, okay, so the overall proportion formula is, so number of results, good results, plus number of proportions value by number of samples plus number of samples B. So number of value of this particular proportion is 41, right? So 41 plus and 351 of drug 2 by and 105 plus 605. What is the value? It's a 0.49. So this is the values. We just need to substitute in this particular formula. Then we will be getting the proportion one. So instead of this one, we can take any one of it. So which one is the giving the positive value that we would like to consider as the proportion one? Okay. So highest value I can take it the forward value, the first value, and which one is the small one, then I could consider this particular one. Okay. Now I just apply this formula here, and my overall proportion is, it's a 0.49. It's a 1 minus 0.49, and so 1 by
20 minutes.
1 by 195 plus 1 by 605. So you just calculated, guys, this value. Just calculated this value. If you calculated this value, here we will be getting, my Z value is, it's 8.99. So 8.99 means, which is greater than this value, right? Which means null hypo we are rejecting, and both drugs are not performing same. That is the conclusion of this particular problem statement. Okay, because of my Z value is not within the range of plus or minus 1.96. It is more than the 1.96, which is in the rejection area. So that I am rejecting the null hypo. So that I'm rejecting the null hypo, and we are stating that both drug A and drug B both are performing in different, not in the same range, the same quality. Clear? So that situation, this jet test of two proportions is performing well. Can you please note it? Can you please note it this particular problem? Mansa, if you have an appointment, then you can leave. Okay.
Yeah, sure. Thank you.
नहीं नहीं यहाँ पे हाई बोल है ना सेकंड हैंड में
Done, sir.
डन सर
Okay, so this particular situation and the same kind of problems, if your data is very small, then how we can able to performing the t-test, we will see now. Where is my pen? Okay. So I'm not giving any proper question actually. Just I'm taking some values of here and I'm doing. Okay. So for example, I have a population mean. Let me consider I have some population mean, and let me consider it's 100, and my sample data it could be 25 only. Okay, and my mean value of my sample is for example 140, and my standard deviation of the sample is it's a 20. This situation, how you can performing, for example my alternate hypothesis, I'm not giving any specific problem guys, just I'm explaining in a general scenario. My my null hypothesis is saying that my population mean which is not 100, sorry, which is 100, my alternate hypothesis which is not 100. Okay, so I want to prove it, I want to give the evidence is my for rejecting the null hypothesis. For this particular situation I don't have any option, I have to go with t-test only. The reason is that here I don't have the population standard deviation, so for that one I have to go with t-test. If you want to calculate at the t-test, and degree of freedom is required. Degree of freedom means the population size minus 1. My sample size is, it's a, sorry, degree of freedom which is equal to sample size minus 1. So here the sample size is 25. 25 minus 1, it's a 24. Okay, so my degree of freedom I calculated is the 24, and my significant value it could be 0.05. Let me consider. See, if it is a one tail test, if it is the one tail t-test, so from the t-table, I can calculate at the my t critical values. So go with the t-table. So from the table, from the internet we can go with the t-table, and here, yeah, so yes, see, tell me what is the degree of freedom? What is the degree of freedom here? It's a 24, right? Yes, degree of freedom is 24. This line, maybe the value it could be in this particular range. Now I'm doing the one tail test, right? If it is the one tail test, so alpha value is 0.05, right? So this value 0.05, then so this is the value 1.71. 1.71 is your, it can be minus value, it can be positive value. If it is the left side, left tile, then you have to make it something like minus 1.711. If it is the right tile, okay, then we can consider as the plus 1.71. Okay, so 1.71 is your critical values. So from the t table we calculated that one. So from the t table my critical values are t critical value is 1.71. Okay, from the t table. So where we are calculated this one? From the t table. Okay, now, and so if you want to calculate the t value, then the formula is sample mean minus population mean by standard deviation by square root of sample size. So sample mean is, what is the sample mean guys? It's a 140. Guys, can you hear me my voice? 140 minus 100 by sample standard deviation is how much? Sample standard deviation is 20, right? 20 by sample size is square root of 25. Okay, so tell me what is the value of t value? 40 by 20 square root of 25 to
10, sir.
10, right? T value is the 10. 10 it could be more than the 1.71, right? So which means that rejecting the null hypo. Reject the null hypo. If it is the one tail test, if it is the two tail test, degree of freedom is 24 only, alpha value is the 0.05, then 1 minus so alpha by 2 in the sense 0.025, so 0.025, right? So you have to remember this value 0.025. Yes, alpha value is the 0.05. Okay, if it is the two tail, here only which is mentioning two tail, right? Two tail alpha value is 0.05. If it is the one tail, alpha value is 0.05, this one. Okay, for two tail, right? Two tail alpha value is 0.05. So then we can drag the line something like this, and 24 is my degree of freedom. So here 2.064, 2.064. So the value what we calculated t value, if it is the more than this value, then we are rejecting the null hypo. I hope you are clear my point, right? Did you clear my point? From the t table, with help of the degree of freedom and the alpha value, we are calculating this value. Okay, and previous one, with help of the alpha 1 minus alpha or 1 minus alpha by 2, that value which is fall in any z distribution, from that one we are calculating the z value. Okay, so that is the thing we have to remember it. So this is for today's class, guys. I hope you understood, and please note this one. So we calculated the null hypo and alternate hypo. We understood the what exactly the null hypo, what exactly the alternate hypo we are understood. Alpha value is 0.05, and we are applying the two tail, right? So you are applying the two tail test. When it is the two tail test, here the degree of freedom is 24. Okay, so these two values we can check in a two tail. With the degree of freedom is 24, the corresponding value we can find out t critical value. This t critical value which is far less than the t value, then reject null hypo. That was we did it with help of the z test and the t test. With help of the z test and t test, we can accept or reject the null hypo and alternate hypo. Okay, please note this example, guys.
Hello.
Yeah.
Yeah, so here I have a small doubt. So here it's a two-tailed test. So alpha we would be considering it as alpha by 2, right? Which in fact would be 0.025.
If
So
you're
can you just see the T table, how we selected that?
if you're calculating the alpha value is the alpha by 2, significant value is alpha by 2, then we can go with one tail.
Oh,
You can go with one tail corresponding. Okay. Did you got my point?
okay. Okay.
See, if you are changing the alpha value is alpha by 2, then
Mm.
the two tail which is converting as the one tail. So
Okay.
if
So we are considering a single tail. Okay.
yeah, if you're considering the single tail, then it's a 0.05. But defaultly, this table which is mentioning the two tail, right? By the
Mm.
time of two tail, the alpha value is 0.05 only.
Okay. Okay.
Got it? My point.
Yeah.
If here it is not mentioned the if you are not mentioned the two tail information, only the table which is mentioning only one tail, that particular situation alpha we have to alpha we have to make it by 2.
Okay.
Okay.
Oh, got it now. Thank you.
Yeah. So this is for today's class. I hope you guys are understood little bit of statistical knowledge, and actually this statistical information we will see when we are using when you are building some machine learning algorithms. Anyway, from Monday onwards, we are going to starting the new Python class from the first class onwards. Okay. So if you are new to programming, you don't worry. I will start from the scratch. Okay. And meanwhile, if you have a time, Deepika, do you have the time? What is the time now?
For me right now it's 8:20 a.m.
8:20 in the sense, 8:20 in say approximately 8:30, right? At that
Yeah.
9:30. 9:30, is it possible for you? 9:30 to 10:30 in your time?
Yeah, okay. I can make it work.
So we will have the classes from Monday onwards, 2 sessions. One session is Python, one session is deep learning. Okay.
Okay. What will be the timings for both of them?
So 1 hour, 1 hour. Maybe it can be less than 1 hour, less than 1 hour.
Okay, okay.
So what time we are considering, what time we are taking the statistics class, same time I would like to take it the Python. Okay. After that one, I want to give the 1 hour break, and then after I would like to start the deep learning. Clear?
Yeah, works.
Yeah. Good enough. And so anyway, we'll catch up by next class. Take care. See you. Anyway, I have your number, right? I can message you for
Yeah.
timing issues. Okay.
That was in a bundle on the